development. Actually, remembering how to do C that you forgot 15 years ago. But it's fun. It's fun. We're going to be making a game and trying to keep it simple. So let's jump into it. I know a lot of the Twitch people are still watching the ads that start and stuff. So I'm going to go ahead and jump in. If you don't know what to do to get started, just once again, we're using Head First C is the book. You can get the PDF online if you want, or you can pay for it and get it that way. It's a pretty old book. I bought 2 copies, a Kindle and a paper, so I have the PDF that I'm going to be using from tonight. If you just want to work through it with us, that's fine too. And we're going to jump right in. So you need to have Linux somehow. I'm not going to get into how you need to have Linux. You need to figure that out yourself. And you need to have GCC installed, at least, relatively new. We're using 10, which comes on Pop! OS. I'm using Pop! OS Linux here. So let's jump right in. Get authentication or something. Yeah, absolutely. Use SSH for Get. Yep. Yeah, we're not going to be covering Get authentication or any of that stuff. We'll cover that in different courses. Just to let you know, I'll show you really quick the courses that are coming up. Actually, let me go to, this one. Zet Edit courses. These are the ones coming up. We're doing C game development and Head for C for now until we finish. I don't know how long it's going to take. We're going to work through the whole book, and then but the stuff you're asking about, people are asking about Git and such, and we'll be covering that either in Bash PowerShell native or learn Python and go the hard way. It's kind of a standalone thing. Git and GitHub are kind of a standalone unit. Yeah, we should probably do that. We should probably do Git, GitHub, and GitOps. Now we're gonna start getting started with GitHub. What are we gonna version? What do we want to call it? Is version management or version control? And GitHub. Switch in. So we're going through the book. I'm just gonna do what's in the book. Bash and Python. What have we done until now? We've done other things during the year. If you guys want to know for 2021, so give her boost. So I mean all this setup up Bash and Linux and getting going on Linux, that's all covered in the boost. We didn't cover VMs though, so I done it from a Docker container. So you should know how to set up a Docker container. You can do all of this from a Docker container if you know how to do it. If you don't, then just get GCC. So the stuff's designed to go together, but we do need a boost that's just Git and GitHub, I think, because that relates to everything, and I don't know where that's going to fit, but we'll figure it out. We'll get a badge out of that and everything. All right, so let's get on the road here. I got to get back into my repo where I was before. Oh shit! What did I do? All right, so we're headed to. Where are we going? We're going to, what do we call it? Was it lab? I don't remember what we called it last night, guys. People. Lab, multi-call, lab swagger, lab interfaces, Jupyter Hub, no. Helm the hard way. I can't remember what we called it. Head first C projects. Okay, there we go. Head first C projects. This was kind of our thing. All right, so I'm going to set my tmux so I'm in here now. And I'm going to go ahead and split the screen here so y'all can see. I know that's kind of a lame way to do it, but it works. It's not, yeah, it was just head for C. It wasn't even a lab. And that's fine. I mean, I probably call it a work through. I might create a prefix for all of my common book work-throughs at some point. But that's it. Okay, so where were we? We were using Head First C, the PDF. Only got 12 people back. Not that many people want to code C, I guess. Yay, game dev. So I'm just going to jump right in, even if people are late. I don't care. I mean, I'm kind of late too, so What programs have you created? I have created Adios, Bad Boy, and Bet. Cute. That's dedication. Shut up. All right, so we did this one here. We're going to do this one. Here's your switch statement, right? Low level programming is good for beginners, so I agree. All right, so we're going to make another one. We're not really getting into what these are. We're just typing it in so we can get practice typing in code. So this is making clubs, diamonds, hearts, and spades. And we're going to make that code. So we could just edit suits, I guess. Suits.c and include. We need to include. We're going to explain all this later. The book does. I'm just typing it in for now for just to have fun. That says use. If you don't have that, you can't use put s or anything because there's no functions defined. So every C program has to have a main. And we're going to int. What did it do? It declared a suit. Okay, so the suit is H. I mean, we could change this. So you notice how that uses single quotes, where that's going to be significant later. That's a byte character. It's not a Unicode character. It's super important. You know the difference. That's why I like Go so much. The people who invented Go invented Unicode. And a lot of C originally. They were participants on it. Dennis did most of it, but case H. What else we got? And the default. Super trash Geo. Default. So we're going to put S and break. This is going to throw me because there's break automatically in Go case statements. And there is not in C. So we'll put that here. That should have, I don't have a linter. I do not have a linter. I guess that's not standard. All right. I don't know C style very well. I've always. What's that? You should have a super trashed EO. Or they should have an STD. That's how I remember. Case. Are we just put S-ing? Yes. Put S-ing. Clubs. Diamonds, hearts. Is there more? Clubs, diamonds, hearts. All right. Club. I should probably turn my ASCIIs on for y'all. Diamonds, hearts. All right. These need breaks. Otherwise, oops. Otherwise, it doesn't know what's up. And I wonder what the default is. Default is spades, I see. And it does not need a break. There's some C code. C restations. But without break and C, it will go through other cases. Break will leave the switch statement completely and proceed with the rest. It falls through by default. So in Go, there's a fall through keyword that makes you fall through. I think Rust is the same way, right? Rust by default does not breaks. And I think Go by default, I know Go by default breaks. So if you want the fall through behavior, you have to put fall through. It's the opposite of C. C defaults to fall through and forces you to type break every time. How's it going, Og? So this should compile, make suits. And we set up our, uh-oh. What did I do wrong? I'm sure I've done many things wrong. Suitsy. Oh, I have to do the switch statement. Whoopsie. More time than I should have getting my ship to render on the window. Oh gosh. Well, I'm sure it will work. Before case. Good old semicolons. Oh. Yeah, thank you. There we go. So Suits. Hearts. God, you see how fast that was? Fuck. Hyperfine. I want to see how fast it is. I'm just getting, this is a benchmark program that tests how fast something is. It's statistically, I mean, my God, this 0.3 user millisecond time. That is fucking crazy fast. I mean, compared to like a Bash or some interpreter language, it's insanely fast. Because it's C, right? Right, we're finished with that section. We're not going to fill this stuff in. You can fill it in if you want. You know that this is a comment. This creates an array of 20 characters. Let's go ahead and I'll just read these to you. We've gone through them all, though. So the switch statement, as we said, this says, hey, pick one of these things. And we set it right here by default. Usually it's from input of some kind. And then the H says, okay, match this and do it, and then break out. So that's what happened. But what does a complete C program look like? To create a full program, you need to enter your code into a C source file, which we just did. We did all that. Okay, so you put it in a source file, and it's telling you you have to have this. And it includes section. C is very, very small language. It can do nothing without external libraries. So we put the libraries on, and that's what this is. So we have include, and frankly, I think I did mine wrong style. Yeah, I did. I did Go style. I'm going to do C style, so the thing goes on that. And then we have the body of the program goes in here. You can put comments at the top. And then, you know, we include, this is where we get put S and scanf. They all are living in this library. That's why we have that. Last thing you fill in is a source file or functions. Everything has to be in a main function. This is the same as every other programming language, including Python. Python has a main function. It's just a default. If it's not put in there, everything goes within the main function. Go has to have a main. I think Rust has to have a main as well. Start files with .go. Lead to a bit easier program. Oh my God, don't say that. Where you put the brackets after the function or in the next line. This is the leading style, is to put it on the next line. It doesn't matter. You can put it up here if you. That's, I think, Linux kernel style does that. It's either that or GNU style. I can't remember. There's massive fights in the world about the style of C. None of them actually matter. There's another group of people who think that everything should be like this. That, you know, so we're just going to go with the K&R style conventions that are in here. And Linus Torvalds actually wrote something about style that I think is a pretty good middle ground. C style guidelines. Yeah, you follow that. So yeah, we do whatever's in the project, but the Linux coding style is defined by a PDF that Linus Torvalds wrote some time ago. Where is it? Can't see if I can find it. 8 space tab or else. Yeah. Yeah. Okay, I think this is the one. Indentation. So this is Linux kernel coding style. This is the style I'd like to follow. Tabs are 8 characters, and this indentation is also 8. So there you go. I'm gonna change my rules for C actually into my Vim on this because I want to use C. I want to use C style guidelines. We should probably use a linter eventually, but you know. I'm going to actually add a Vim rule because I want to use Linux kernel. I want to get used to Linux kernel style because I want to commit to Linux kernel at some point. Like in the far distant future. So, I mean, who knows? But I wouldn't like to be able to make a C driver for Linux, and that's also like C style. I have a way of setting the tabs here somewhere. I can't remember where it is. Let's see. Oh, that's not it. I can't remember where it is. I have like an explicit type check. Let me just spend a second finding this. There it is. So I have .go set spell. I could do .c. I mean, this is really sloppy. I wonder how many tabs we're gonna do. I can set. I don't know. I thought I did one already. I got Pearl Tidy on there. Go meta. 222. I think it's is it tab stop? Oh, there it is. There it is. Where's my C one? All right. All right. So up here, yeah. File type. File type C. Actually, let's see this down here. This tells me the file type is right here. Oh, you can't see it's behind my picture. I'm sorry. Probably move that up a little bit. This is going to be in here so much. Like that. Right. See, this is like C. And that's what I was looking for. All right, so I'm going to do set equals 8. I'm pretty sure that'll cover us. Let's try, though. vi bet.c. Let's try this. Tab. Yes. There we go. 1, 2, 3, 4, 5, 6, 7, 8, which is down here as well. You can see. So, yeah. Now it's not going to lint it. I don't have any linter set up. I have nothing in my C environment set up. I need to get it set up. So eventually we'll do that. God damn. That's a pretty long ass indent, but we're going to do it. So let's go back to the standards. We're reading this little standards thing. Let's read it real quick. Placing braces in spaces. If statements to switches are on the same line. Initial and stuff is on. It's a different line, like a function. And yeah, there we go. Functions go on the there's a special case for functions. Everything else is on the same line. Else ifs are on the same line. Basis. So there is the style guideline. Yeah. Linux kernel administrator's guide. No, let's go back to Linux kernel coding style. Copy. I'm gonna put this in our notes. Put it in my notes. Let's see. We'll be following Linux kernel coding style. And I make a little link to this. Give me 1 second. There we go. A little bit of common mark here. And that is it. Now, I have not done that out so far, so, you know, I'm going to have to come back to it and fix that on my next ones. But we're ready for that. Back to our document. So, any questions so far? Anything else? Anything new? Which I'm not using a plugin at all. I'm just using the default Vim stuff. Yeah. And I can add. I don't want to add it there because reasons. I'm just using the default one. I don't want to change .vim FT plugin because I don't have a symlink for that yet. So I'll do that. At some point we need to come back and really find a good syntax plugin or a linter for C. And I want to just get through the book first. At some point we can come back and add that kind of after the fact. Maybe somebody can find a good one for us. Okay, so this is what a C program looks like. In function in more detail. The computer starts running your program from the main function. The name is important. If you don't have a function main, your program won't work. The main function returns a type of int. So what does this mean? Well, when the computer runs a program, it will need to have some way of deciding if the program ran successfully or not. It does this by checking the return value of the main function. If you return your main function to return 0, if you tell your main function to return 0, this means the program was successful. And if you've done any bash programming, it's the opposite. In bash or POSIX shell or Z shell or any of them, 0 means there was an error. 0 means successful. 1 means there was an error. Oh, wait. It's the same. Yeah, what am I talking about? Yeah, because the integer means you can do a different number depending on the error code. So yeah, okay. If you're, I got that backwards. I'm sorry. If you tell a main function to return 0, this means that your program will be successful. If you tell it to return any other value, it means that there's a problem. And you can put a number to indicate the problem, and that's what they've been doing for years. And that explains the direct correlation between this and bash. All right, there you go. This is an int. It's a type of number, a whole number. Main. That's where we start. It's a special name. It's inside of braces. They call them braces. Some people call them brackets. Some people call them curly brackets. Some people call them mustaches. Whatever. The function name comes after return value. Now notice we have return 0 here. So I have not been putting return on anything, and it's been injected just fine without a problem. Someone called that an error. I don't think so. It works. And the function name comes after the return type. That's followed by the function parameters if there are any. So we don't have any function parameters. That would be arguments that are getting sent into the program. We don't have any of those just yet. We will. So the function body, the body is sometimes called a block of code between the braces. I used to tell the kids when I teach young people to think of the braces as being like the fence posts, and everything in here is like your cattle. And if you leave a fence post off, all the cattle get out. I know it's stupid, but it's mnemonic. Geek bits, the printf function is used to display formatted output. Replace the format characters as special values. The first parameter will be inserted as a string. Yeah, so printf is, you probably know printf if you've done any other programming in any other language at all, which you probably should have before doing this. You know printf because it exists in every other language that I know of. Every other major language. It's in Bash, Go, C, Echo, POSIX, Ruby, Perl, awk. So it just means keep your code contained, kids. Code wranglers. Yes. So %s just means a string. There's other ones, %i for numbers, for integers. Go actually takes this several levels beyond and really makes some cool things. I won't get into it. But I have never, the Golang has by far the coolest printf syntax you could ever imagine. You can print binary with a B. It'll take a number and convert it into binary. You can do V, which just gets it right. You don't even have to know the type. Whatever type is, it'll interpret it automatically. Yeah. Yeah. In Golang, you just put a V there and it'll output the struct as is. It'll make a string version of it very nicely, and not in C. So yeah. If you ever want to check the exit status of a program, do echo error level on Windows or echo $tilde. $? I do this all the time. So like if I'm trying to see if my return value worked, I can do that. So you can do like ls and then semicolon and echo, and you can see what your last thing was. If you do ls blah and then echo, you'll see if it failed. So that failed because there wasn't one. So that's a return code. And that you're going to use that a lot. Actually, you can use that to test whether there was an error in your program if you're messed up because you had to capture the output or something. If you shell check, you'll get that right every time. So code magnets. The college blackjack team was working on some code on the dorm fridge, but someone mixed up the magnets. Can you reassemble the code for the magnets? This is kind of lame. So yeah, let's do this. What would go up here? Guys? So what goes up here? So we could put this up there. Include goes up there, right? Include, yep. And then we would put stud lib up there after that. What else? I think that's it. There's not a semicolon after that. That's kind of weird. Let's see. Return 0. Return would go down here, right? That one's a good one. I don't know what will go here. Maybe a comment, but I don't see any comments. Oh, they have two includes. So the second line would be another include. Include stdio.h and studlib.h. So there's two includes there. Down here we would have what? So what this indicates the return value. So up here we would have which one of these? Int. We have an int there. And we go through the little thing. Else if the card name equals Q, then we need to print something probably. So are we returning? Oh, we're returning. Okay, so we would have a return. I don't know. What does the other one say? Val A to R card name printf. Do we have a printf? I don't get the option for printf. Else if the card name's Q. Oh, I guess we need to set the value. There we go. We just said value equals 10. No, that's for K. So it would be some other value. Value equals 11. There we go. So value equal 11 would go there. Else if card name is 0, then it would be card name is 0 equals, so we did Q, Queen, King, and we need a Jack, probably Jack, an Ace. Where's Ace? So Jack, Ace would go here. This is probably, I don't know, probably it's descending. So K, Q, that would be by either Jack or, why does it say value is 10? This is a bug. We found a bug, people. That is a bug. They have the same value. You see that? We found a bug. Yep, there's a bug on page 7. There's a bug on page 7. Yep, that is not good. That's not good. That's a confusing bug. Are we still in chapter 1? All face cards are 10 because this is a blackjack. Oh, is it blackjack? All right, that makes sense. And ace is 1. Else value equals A to a card name. This converts text to a number. The card has A to a card name. Scanf, Jack, Ace. Oh, I get it. So val equals 11 goes here and val equals 10 goes here. Okay, because it's blackjack. No, I had to adjust them. They're fine. I don't know what it was. There was some volume control problem. I just jiggled them and they worked. They're getting old. So I mean, this is kind of dumb, but that's what it is. So up here is val equals 10. Down here is val equals 11 because it's an ace, right? And a card name equals A. And this would be else if, else space if. And then this would be a J. And then A to I. This converts text into a number. Val equals A to I, else A to I. That means, oh, I see. So they're typing in the other values. 10, you got a 1 of hearts or something like that. Okay, that makes sense. And then the card value is, and this converts the I and prints it out using a printf, which we read about earlier. And then this is return 0. So, okay, we got them. We got them. Moving on. Code magnet solutions. Hey, look, here's the answer. So include int val10. Yeah. Oh, we got the semicolons. I forgot the semicolons. Don't you forget the semicolon. J val 11 equals semicolon return. We would actually have extra magnets left over. It'd be a bunch of semicolons just sitting there. Don't question, what does the card name mean? It's the first character that the user typed. So if he types 10, card name 0 would be 1. Do you always write comments using blah? If your computer supports the C99 standard, you can use the double slashes, which we used the first time. Compiler treats as the rest of the lines are common. How do you know which standard the compiler supports? Check the documentation for your compiler. GCC supports all 3 standards, ANSI C99 and C11. And I don't know which one the default is, though. I don't know if there's like a version. I think we have to give it a switch. So you're not gonna have to worry about it for this project. So, but you might at some point might want to worry. It doesn't matter at all. It's binary code anyway. But how do you run the program? C is a compiled language. I'm gonna read all of this because this is super important. Super important. Pay attention to this. This means the computer will not interpret the code directly. Instead, you'll need to convert or compile the human readable source code into machine readable machine code. So as I said, you got to take the human stuff and turn it into binary machine code. Compiler, you need a compiler using GCC. We already did it. We talked about this. So first you save the code, then you compile with GCC, which we did. We also added some C flags in order to get some warnings and stuff, which they're not covering here. Then we'll watch the video from yesterday about that if you want to do that. Run by typing cards on Windows or .cards on Mac and Linux. And that's just how you run it. You have to do / in order to get it, because that means in the current directory right in front of me. That's a safety mechanism. Never, ever, ever, ever put / in your path. Some people do that. I did when I was a kid because it was more convenient. Don't do it. It's a major security flaw. You can compile and render code on most machines using this trick. GCC Zork. Nobody knows Zork. Zork is a game from my era. I lost many a summer playing Zork. This command will run the new program only if it compiles successfully. If there's a problem with the compile, it will skip running the program and simply display the errors on the screen. You should create a card to compile it now. We'll be working more later. All right, so it looks like we're going to be making a file called cards.c, and I can put the other ones from chapter 1? We can put the other files from chapter 1 into a directory. Make directory. Chapter 1. Chapter 1. And we can put those in there. So I'm going to put all of my C files in there. The compiled programs are not included. This is where make clean would be nice. Actually, we could probably do it. Oh, fuck. Well, I guess not. Make clean would like get rid of all your compiles if you don't want them to clutter everything up. Let's see into chapter 01. And then we're going to delete all the executable files. Find dot type x type file. Oh God. Type file. Well, fuck that. Adios, bad boy, bed, hello, suits. I don't really need run here for now. Run. I'm going to remove Dockerfile too. I'm going to commit all this changes. It's going to do core utilities printf compared to stud printf. It should be fine. I think this is the same thing, top attains. I do. I don't think they're that big a deal difference. Out of the Docker realm. Yes, but I think you should go into the Docker realm if you look, you shouldn't be here if you don't have Linux. The end. All right? If you don't have Linux, somehow you shouldn't be here. So that comes, you can figure that out in other ways. It's not that bad of a deal. All right. Don't feel bad. I mean, we can help you get it. The fastest way to get Linux is to run Docker off Docker desktop on your system and just do the run Docker and run commands. They're done. But the second fastest way is to install a virtual machine, or which includes WSL too, which is a virtual machine. That's the second fastest way. It may be that on Mac you can just compile on Mac directly and not even mess with it. And Raspberry Pis are pretty damn cheap as well if you want to do that. Do they have? Yeah, they do, right? They have SDL cards. They got to. Okay. They have the SDL2 support. They have OpenGL. Yeah, of course they do. Of course they do. I had a brain fart there. Okay, so what are we gonna do next? So on a Windows phone using DirectX Twitch plugin, what is Linux? Shut up. I don't know. No. All right. Test drive. Let's see if the program compiles and runs. We already did that. We've been doing that for the last day. So we're gonna skip right over that. File cards runs as program. Dumb questions. Why do I have to have the / prefix? It means this one right here. It talks about Unix style path. You should already know that though if you have Linux, because we covered it. Wait, I don't get it. When we ask the user the name of the card is when you use an array of characters. What is an array of characters? Why can't we use a string or something? The C language doesn't support strings out of the box. This is one of the reasons I like teaching C to beginners, or to at least at some point in the process. Because you kind of get spoiled using all the other languages by having strings. You don't have strings in C by default. You have a character array. That means an array of bytes that is interpreted as a string. And if you don't know what a byte is, you should already know what a byte is. And a byte is 8 bits, 8 ones and zeros. And one of the projects we do is actually counting in binary and going through the whole bit thing. And if we have time, we might go through that right now. C is a really great language to kind of dig into binary and understand how a series of ones and zeros can be interpreted in many different ways. It can be interpreted as a number. It can be interpreted as a number representing a letter. It can be interpreted as an operator. It can be interpreted as points on a bit field, which means like switches on and off. This thing is on and off. There's many different ways to interpret all those ones and zeros. And that's what data typing is. Data types are kind of projections onto a series of ones and zeros as to what they mean. And you can interpret them in many different ways. In fact, sometimes you can confuse people and obfuscate it by just representing a very basic, easy thing as a series of ones and zeros. In fact, in Go you can do this pretty easily. So you could do printf, and you can do like ~b. Notice it looks similar to C, right? And we'll just say the letter A, right? And we can just run that. And there you go. So there is the ones and zeros that represent the letter A. If you wanted to represent the letters for C, capital, how about lowercase z? I mean, Z. Let's do a Z. And now you see it's got a different set of numbers, right? If you wanted to see what the actual, base 10 integer number for that is, you could put I or N and say, I want to see it as a number. I think it's, it's in 32, 122. Let's do I. Give me 1 second. Let me go run it. No, which one is it, guys? Is it I, N? I think it might be V. It is V, 122. That's the number V. Yeah.
They put some of the classic Mickey Mouse Christmas cartoons on Disney.
Mickey Mouse Christmas cartoons?
Like the classic ones, like when we were
I want to watch them. Nice. Why not run it under Wine? Steam and Proton have run Windows game automatically using Wine. This is true. It doesn't have native Linux support. They're really jerks. We started teaching Roblox. Roblox is fantastic to teach programming. Lua programming and Roblox is one of the best ways to teach kids how to code. And you can't do it on Linux, so I had to abandon it. If they even find out that you're trying to run Roblox in Wine, they will banish your account because they're anti-Linux. And I stopped doing anything with Roblox after that. I'm warning you, if your kids like all of that money that they've got in Roblox, and anybody gets a whiff of you're using Lutris or Wine or anything on Linux, they will ban your account and take your money away. I wouldn't risk it. They're real dicks about it. It sucks. It sucks. When I heard that, I was like, I am done with this company. Yeah, go research it. It's insane. They apparently had some people on Linux hack them really bad and steal actual money because, you can, the whole Roblox thing is you get people to play and that you get Roblox coin or whatever, and it actually translates into actual money. And so there were hackers that were doing it to get real money, and they just freaked the fuck out on them. And rather than supporting it and fixing their own bugs, they banished Linux permanently. So yeah, it's really, really, really lame. I won't even talk about Roblox anymore after that. It's too bad because it's a really amazing way to teach kids how to code. Because it's something, it's like Minecraft, but with coding. There's some ways to do it with Minecraft more now, but there's even really good ones that you can use, but you have to be a Minecraft education member, which means you have to be a member of a school and blah, blah, blah. RCA, once C class is done. We haven't talked about the RCA, but yeah, when it gets done, we can do that. We have another half an hour or so. C language doesn't support strings out of the box. C is a more low-level language than other languages, so instead of strings, you know what a string is, by the way? How people don't know what a string is? I actually used to have a thread with beads on it, and I would, as an object lesson for 9-year-olds, right? I'd say, okay, this is a string. You have a piece of string, and you have these letters and numbers on there, these beads on there, right? And what happens if you don't put a knot at the end of the string? All the beads fall off, right? And so you have to put a knot. Well, the knots are double quotes in this case. They're the double quotes. That holds everything in. And one of the number one mistake that beginners make, young beginners like 9, 10-year-olds, is 11-year-olds, is they forget to put the closing bead on there. So you understand, I have taught C to 10-year-olds. I've taught Python to 9-year-olds. I've had them writing programs. So, and to get their minds to grasp some of those things, you have to get creative with your, and I used to make a hat. I had a hat and I would put a value, and I would put that value in the hat, and only one value could be in the hat at the time. And that was a variable. So whatever was in the hat was a variable. And null terminator not as well. Yeah. And C, you could probably use it. I haven't taught 9-year-olds a lot of C, actually. When I say C, I meant Python and JavaScript mostly. But yeah, Python, actually. Python was the main one. Back then, we didn't get as many. It was mostly 12-year-olds, and they'd already been through college algebra. We got kind of picky eventually because the real key distinction between people who pick up languages like coding easy and those who don't is linear algebra. Kids who have had pre-algebra or linear algebra of any kind can immediately just get running with coding. Those who have no concept of what a function is in math struggle really hard. You can get over that by teaching them Scratch and stuff like that, or really spending time with them to get it, and then they're going to do better in their math classes. But sometimes it's better to just wait until they've gone through math. And in America, you don't get linear algebra until you're 12, which is fucking insane. I can't believe they're waiting that long. It just makes me angry. I actually put together a curriculum. I never did it, but I put together the beginning of a curriculum called Math for Early Programmers. And all it did was teach the basics of functional algebra, x equals, f of x equals 2y and that kind of thing. F of x equals 2x. What am I saying? Yeah. So here you go. So an array is just a list of things and it given a single name. So card name is just a variable name. Now, it doesn't tell you what a variable is. So a variable is, again, if you've had math, you know what a variable is, right? If you haven't had math, you don't know what a variable is. A variable, you can think of it as a box that holds a thing, and it holds a value. It can be a big value. It can be a small value. You can also think of it as kind of a pointer, which it literally is, to a thing. And you can when you change the value of a variable, you're actually not really changing what's in the variable, even though in your mind it's easy to think of it that way. You're changing what value is being pointed to. Sometimes you're literally changing the value, but more often you're changing what's being pointed to. And we're going to get into that a lot in C. C, I don't want to get ahead of myself, but C is really fantastic to understand what actually is happening when you put a name into card name. What actually happens at the computer level? What's going on in memory? And so it's actually really great. I'm really excited. So the card name is just a variable name it's used to refer to a list of characters entered in a command line prompt. You define card name to be a 2-character array. So you can refer to the first and second character as char name. By the way, you know, this is called snake case by some, modeled after Python. But you know, I mean, C was doing this way before Python was a thing. It's still called snake case, so that's what that is. It's underscores. Perl uses that. Python uses that. Some people use it in Go still. It's the science of it says it's more readable than camel case, even if it's less efficient for the compiler, but whatever. And char name equals 1. To see how this works, let's take a deeper dive into computer's memory and see how C handles text. We're going to spend a lot of time on this because this is the real value. Ruby uses it too? Yes. A lot of the earlier languages do. I actually really like to use that in Go, even though it's not standard Go. I like to use mixed case for structs and stuff like that. And then, but when I have variables that have to be long, medium-sized variables, I personally like to do that in like functional scope and stuff like that. But that's not standard. It's supposed to be mixed case for Go. So anyway, strings way up close. We are going to read this completely. It's so important you understand this. Okay, and Python is actually really good at understanding what strings are as well. Python is really good. You may already know this from Python. So strings are just character arrays. When C sees a string, S equals Shatner with double quotes. All right. If you've done this with Python, if you learn how to code in Python or JavaScript, you're like, why can't I use single quotes? Single quotes mean I want a single character. Much different thing. Same with Go. And when you have double quotes, it means it's a list of characters, a character array, otherwise known as a string. I'm going to do this in Python so you can see. So if you do Python, I'm going to do Python 3 just to be sure. So you can do Python. You can say name equals RWX Rob. Now, I keep doing single quotes because they're easier to type. Watch. So I can do, print name. And I get the name. I can do print name 1. And what's it going to give me? Not the first one, right? It's going to give me the second one. If I can type it. It gives me the second one, right? Because why? Because Python and JavaScript, Node does the same thing. Do I have Node on here? Yep. So you could do this in your web browser if you want to do that. So you could do let name equal RBX Rob. I don't use semicolons, but whatever. And then you could do name. So name, it gives you the whole thing, or you could do name 1 and you get the W. Same idea. So all that stuff comes from C. And you can iterate over them. You can iterate over them too. So you can, we haven't got an iteration yet, but we will. So you can like loop over each item in there if you want to, or you can split the string, and basically you're just handling it as a list that you can divide however you want. D. All right. So let's go back. So here we are. We got another 10, 15 minutes. So it reads like it's just as if it was an array of separated characters. Now this throws people who've been from other languages. And I'm glad I'm seeing this again. This is helping me remember. Normally in other languages, when you see brackets, you are not thinking of a list. What are you thinking of? Anybody? Anybody coding in another language? What do brackets, when they're surrounding something, some kind of data, what do they usually indicate? It's just one substantial difference from C from everything else. It's usually, yeah, it's well, I mean, it's usually a dictionary, right? And a dictionary in Python, in other forms in Go is called a map. It's also called an associative array. So to do this, let's do it in JavaScript, for example. So Node.js, we could do Node.js. We could say name equals, well, let name equal, we would do like R, W, X, this is hard, comma, R, comma, O, comma, B, right? All right, now if I type name, it still thinks of it as a list, right? And a hash map, yeah, or an object. So the crazy thing is that it's the same thing though. So like if you console.log name, isn't that weird? Why? Because it's a different type, right? Raise it 0. Yeah, they start. Oh, that's not completely true. I got beat up over that. Lewis starts at 1. Fortran starts at 1. So there's a couple languages that don't. Now, in order to get it to treat it like a string, I have to cast it. We haven't done casting yet, but I don't think I'm doing this right. How am I doing this right, guys? Is it toString? I can't remember my JavaScript. Is it toString? Fuck. Is it named toString? Thank you, Ty. Thank you, Ty. I feel insignificant. Well, I started as an array. No, this is node. I tried to do string, but it didn't work. I guess that's a string representation, but I made it as an array list. That's super interesting. I'm learning something here. Yeah, this is interesting because it's not joined. Okay, so this is node. Don't confuse this with C, right? And by the way, there's no interactive REPL in C because C is compiled. You only get that with an interpreted language like Perl, Python, Ruby, any of those. So this is how you do an array. Let's actually make a program that prints out Shatner, shall we? So let's make one. Let's say in chapter 1, let's make a program called Shatner, Shatner.c. Remember what comes here? What comes here? Think about it. What comes right now? What's the first thing? Import, right? It's not import? I used to do this with my kids all the time. Okay, we need a shebang line, right? We need a shebang line, right? Stud IO include. No. Just let me live a memory. It's just a memory. I used to do this with the young people, and they'd be like, "No." Super tragedy. Import. No, it's actually include, right? Include. I'll white. Studlib.h, right? There's too much lag to do this. No? What is it, guys? Is it studlib? All right. I'm going to pretend like you're stumped. It's stud.io. Okay, there you go. And then we have func main. And we go on like this. Let's see if anybody catches that. Func main. And then we have a character indent. And then we do s equals. I'm really screwing everybody up. Because this is Golang. No. Int main, right? And then down here, instead of a bracket, you have s turned into your statement. I really like how you teach. This is I've been teaching young people for a long time, so thank you for saying so. Appreciate that. This is a little bit annoying though because it doesn't compute for me. So you want to see me to do this a lazy bash way with a filter? Yeah, watch this. For I in no. How crazy should we get with this? Standard income. I mean, we could write some Perl or Python code to write the C code. Don't listen to my bubbling. Yeah. All right. So SHAT. God, this takes forever. I'm too lazy. N E boomer reference R semicolon. Put S C S. Put S S. All right, let's run that baby. First of all, make Shatner. Oh, fuck. I mean, something else because we have 9-year-olds here. Whoopsie. Get it? I don't think I need it. Do I need it? I probably do. It's not declared. Type's not declared. I mean, let's declare it first. That's kind of deceiving. I'm glad we hit that. I'm glad we hit that because they don't cover it. So let's actually do a declaration on a separate step, right? So this is a character array that has any number of characters in there. I can say I want 10 characters in there, right? And then I could put more than that. And this is where the memory thing comes in. We're going to get into this. So, uh-oh. Expected expression before the token. What's up with that? What did I do wrong? And it does, but someone said it's UB. Sure, it's 10. Oh, duh. I'm coding Go again. I'm sorry, I'm coding Go again. This just makes you guys better because I suck. Expected expression before token. I guess it has to be on the same line. I was not expecting it. I thought you could like separate them out, have one be declared. What am I doing wrong? I mean, I know I'm almost positive this will work. Oh, because it has to be cast? Really? Is it the playtest that doesn't work? Error expected expression before token. This is interesting. This is, oh. Did I have a semicolon? Was I missing a semicolon? Are you fucking kidding? Was that it? Thank you for the semicolon. It's after the brackets. You think so? That's interesting. I didn't think you needed that. I mean, I see why the cast is working, but I didn't think you needed it. I think you can declare and initialize separately. This is really interesting. I'm learning something here. So, this means you have to initialize and declare on the same level. I have a feeling. If that's true, that's very different than Go, and I'm glad I learned it today. Oh, we have to do string copy? Arrays are immutable in C. Oh, that's right. Thank you for the reminder. I totally actually, arrays are immutable in Go too. Slices are what's screwing me up. This is really good. This is really good for me. What are we doing? We're programming in C. Yeah, this should work now. So they're immutable, which means it can't be changed. Immutable means it can't be mutated. There's no mutation. You can't mutate it. It's immutable, right? Mutable means it can be changed, right? So you can say, and I can say like pedantic asshole stuff like, it's an immutable truth that all languages that have semicolons are superior. Then you can fight about it and smoke your pipe. All right, here we go. Make Shatner. What? Shatner has worked. I feel a little dirty saying that. Shatner seems to have worked. Because I am reminded, thankfully, that arrays are immutable. They can't be changed. Once you set them, you can't change them. You actually can change them. You can change arrays. I guarantee you can change arrays. I'm going to try it right now. You can yell at me. I'm going to try to change the letter in here. Yeah. I want to make the S capital. So you can add them. I want to see if I can change it. Watch this blow up in my face. Watch this blow up in my face. I'm trying to change the S to make a big S. Arrays are not immutable. Yeah, I don't want to teach false truths. Well, that does not mean they're immutable then. That is not immutable. That's the opposite of immutable. All right, so I could have sworn. All right, so yeah. Oh, I don't know. Maybe they are. It didn't seem to work. I don't know. Googling know more about Log4j vulnerability. Google and helpful. Let me know that Log4j is. Oh god. Log4j. Somebody just. Did I not make it? I always do that. I always do that. There we go. Yep. Now, absolutely. I mean, now that I think about it, that's silly that I thought they were immutable. I had Rust on the brain. Obviously, Rust strings are immutable. Yeah, you have to borrow check them or set them as unsafe or something like that. Arrays in Go are not immutable. Are arrays in Go Lang immutable? I don't think they are. I think they're the same as C because it's very compatible with C. Immutable struct. Java Lang. All right. Nope. Is there learning how to store multiple arrays in a single value and arrays a data structure consists of collection of data? You can actually change the value of an array in Go. I kind of want to test that, but not right now. I like polyglot stuff. Why I can apply it across the board. Static data. You'll be thinking of when you declare a string pointer to a literal. Yes. Yeah, that might be it. Yes. Just for tutorial's sake. I mean, this is good though for beginners to see. So I did not know that you cannot declare something. I still don't believe it. There's a part of me that doesn't believe it. I wonder if it's scope of declaration. Oh, no, because S would have to be a pointer. Oh, I see what I could have done. I could have done a pointer test. I don't want to get into pointers. Okay, that's what I'm remembering. I'm remembering pointers. Hey, Mr. Yokanzu. Yeah. Yeah, I totally forgot that pointers are what I was thinking of. Yeah. So this is good. This is really good. So this says put your pattern. By the way, this is exactly the same as this. Which one do you want to type? The difference with this is this has, kill me if I'm wrong, people. How do you do a null byte? Is that it? Am I getting this wrong? I'm experimenting because that's how I learn. And all right, so even though there's 10, we're going to get into this. We're going to get all of this, right? So there's 1, 2, 3, 4, 5, 6, 7. Right now, let's see. Yeah, so there's 7 characters, and then there's a null byte. And that means that there's 2 characters that are wasted. It's just a special notation. Yes, right. It's a special notation for 0, which is a null byte. So strings always have a null byte at the end, and you can get into trouble by not having null bytes at the end of strings. But the important thing here is to see, and this is why C gets in trouble all the time, is when you do it in string notation like that, it adds one automatically, right? And that's how it knows the end of the string. But in both cases, in this case, actually in both cases, I think, this is wasting 2 bytes, right? And so memory allocation and how many bytes you're this is the thing. This is the thing that gets you into trouble. It's the thing that makes it really powerful because it's low level, and we're going to get a lot into that in the Go thing. We're almost done for today, but I wanted to get you into this. So again, how many we got? We got 1, 2, 3, 4, 5, 6, 7 characters, and then the null byte character, which is the last character. So 8 characters. That means that there's 2 wasted bytes. 2 wasted bytes in this allocation, and they can't be freed. And anytime somebody gives you shit about garbage collection being a bad thing, garbage collection it's a very simplistic way to put it, but the garbage collection is one of the ways that languages have gotten around this problem of wasted memory. And I know that there's a lot of technical details to explain to make that happen, but in a garbage collected language like Python or Go, they would make use of that stuff at the end. They would reuse it. It would be more efficient, and it would just work. And so all of that work is on your shoulders in C to make sure you take care of your memory yourself, or to write in your own garbage collection. Because C is very, very, very low level. And C, you can make your own garbage collection. And that's why people like it, because they have total control over their own garbage collection. You can't do S8. Yeah, in fact, watch. If I try to read, isn't GCC garbage collected C? I don't think so. Lol. Let's try this. All right. Let's try to change the byte after all of that. So counting from 0, 1, 2, 3, 4, 5, 6. So that's index 6. This is index 7. So let's put something at 8. Let's put a Z at 8. All right. I think he knows that. I think he was, the kappa is him being ironical. Mind's eye knows is C. You can't predict the final array size. That's also a problem, right? Because you don't know what size bytes are using a thing. So, but let's try it. Let's try it. What do you think this is going to do? Take your bets right now about what this is going to do. How is this going to change the program? Is it going to crash? Is it going to print Shatner? Is it going to put Shatner and then a space and then a Z? What's it going to do? You know, and I could run a poll right now, but I'm not because I'm lazy. So just think about what you think it's going to do. But this experimentation, I want you to do this when you're coding C. I want you to try to fucking break it. Not only will it make you a kick-ass hacker, because you'll know how to break code. You'll be reading through code on GitHub or something like that. You're like, oh my God, I can totally hack this shit. Because you'll know how to do it. You'll also write safer code. So I'm going to encourage you to break your own code while you're writing it. Break the shit out of it so you know why it's breaking. The biggest danger of Rust is it prevents beginners who are learning it as the only language for their first language from learning how to break this code so that they can deal with the trillions of lines of C that they're going to encounter in their life that are already broken. And that's dangerous. I think learning Rust without knowing C is really dangerous. I suggest you learn at least both. If you want to try Rust and dabble, fine. But, you know, yeah. What do you guys think? Yeah, either it doesn't compile or crashes. All right, let's try it. Make Shatner. Oh, look at that. Compiled just fine. I think there are 2 zeros because of 10. Let's see what happens when we run it. What? Yeah. I think you're a little confused. Okay. If you're confused right now, I'm going to try to explain it, but more importantly, I want you to understand why this is working, because it's doing what it's supposed to do. And it put S will put up to the first byte. Yeah. So this isn't really fair, to tell you the truth. This isn't really fair because put S, the function, knows about the null. I kind of did this on purpose. Put S is cheating because put S knows about the null. It knows about the null, and so it goes up to the null and says, "No, I'm not putting anything past the null because I'm a safe, happy program. I mean, output function." There are other ones, I think. Let's try printf. Should we try that? We just learned about printf. Let's see what it does, right? So let's say it's a string, so we'll put S. And we'll print S this way. We'll see what this one does. As I said, break the shit out of it. Experiment. This is a better. I mean, I don't know what the book's talking about right now. It's probably going to cover all this stuff, but this is a much better way for you to get, your hands dirty. So .shatter, okay, compiled. Look at that. It still worked. Now, it didn't put a line return. That's another thing put S does. Put S also gives you a line return, \n, which you should know from any kind of coding in any other language. We'll iterate over the string. Yeah, that's a good thing for that ancient. Let's do that. Let's actually do all of them. So let's do print. No, let's not, because it'll run into each other. So Shatner, look, still prints it, right? But what Ancient Straits has just given us, he's kind of, thank you for that, Ancient. I didn't want to go lurk at it out. If you don't understand this code, that's fine. This code loops over each position in the array. So this loop, this is a loop that's treating the code as if it is an array and not a string. So it's going to print every single character all the way up to its maximum size, or actually until this. But you know what we could do instead? Why don't we do length of 0? How about that? Can we do, what would it be, guys? It would be I is less than len is less than len s, right? I get it. So we don't know about that yet, but so this is going to go all the way up and give you everything. Did I do it wrong? Don't yell at me. Is it size of? I'm doing go again, aren't I? String lang. I want to go past it though. All right, fuck it. I'm doing 10. Should do sometime. I do on Sundays. Yeah. String will be 8. Size will be 19. Yeah. We want it to be less than 10. Size of it would be the number of bytes, right? Size would be 10. I was gonna say. Yeah, let's do size of. Size of is the size in bytes, if I remember right. So you guys are helping. Thank you. So let's do that. So less than the size of s, but you want to get used to that. By the way, we're kind of jumping ahead, but this is just a loop, and don't frantic about this right now. Let's make sure this compiles. Make shut. I wish make had completion. This is annoying. Oh God. S of. Oh, duh. Sign comparison. I'm getting an error. What's wrong? Oh, tilde C, right. Right. I'm kind of completely off on this. Duh. All right, thank you. So that's a character, a single character, a character which is a byte listed as a character and not a number. So what else is wrong here? Anything? This comparison is not working. Side is an unside. Is it? We can put, is it uint then? What's unsigned in? I don't remember. I thought it was uint. I'm used to the Go stuff. Is it actually unsigned in? You fucking kidding me? Oh God. Put C. Put C for the single one. Yeah. Nope, still not happy. Do I have an S in there still? Holy fuck. I thought I got rid of it. There. That's, at least it didn't core dump. Goes uint is unsigned in. Nice. Hello, how's it going? Gothic Cat. What a name. No new line song. There we go. Nice. All right. So, are you seeing what's happening here? This is kind of fun. This is fun. I'm going to keep this code here. You guys go look at the code later. Let's do this. Let's do, we'll put an I here for the number. Right? Yeah. Yeah, we can put an I there. What we could do? We can make this an int. No, let's just put the index. Yeah. And we'll put it is it I or N? It's I, right? Okay. And then we do I, comma, and now you can get it, you can see it nice and pretty. Is it D? I want it to be the number. I is an int, right? Or is it D? I can't remember. I can't remember. It's been so long. I or D? It is I or D. Okay. I is integer. Okay, I'm not completely idiot then. So there we go. That's what I wanted to show you. Now that, isn't that useful? Look at that. Look at that fun thing that Ancient everybody helped us make. So this shows us that a string is actually a bunch of characters that are bytes. And I'm using the word character on purpose. In Go, they call these things runes because they vary in width, and they're Unicode aware, which is really fucking awesome if you know what a big a deal that is. Characters, I want, when I cover this, I want you to understand something. An emoji, an average emoji, is not 1 byte. It's 2, 3, or 4 bytes, which means, and a byte is 8 bits, right? Okay, we looked at, right? When you're dealing with C, you're dealing with bytes. Unless you explicitly make another type or import it or something like that, you're dealing with bytes. That means you're dealing with 8 bits. And that is a big fucking deal, because if you think you're going to make a C program and you're going to put emojis in there, or you're going to use kanji text or any number of problems, you have a massive issue to deal with. And that's why, read about UTF-8 is encoding for some interesting stuff too. It's super interesting the way but since we're covering this topic of character arrays, I'm deliberately calling them characters. And by the way, when I do Go, it's crazy. Circuit pairs is amazing. When I do Go, I don't ever use the term character unless it's an actual character. A character is an ASCII, usually an ASCII character interpretation. ASCII means there's only 256 maximum of them, and they are direct translation to a number, right? So this is why you see so much stuff in basic, not the language, but in ANSI, in ASCII, not even that. It's usually only 128 because the ASCII symbol table from 128 up to 256 is kind of nebulous. Most people just discard it because it's been used differently by everybody. And if you don't know what I'm talking about, let's go spend a little moment talking about this before we close tonight. Go look up the ASCII character table, and you'll see where the numbers translate, right? There's lots and lots of these things. Oh, wow, there's actually one that pulled up right there. Look at that. So you see here the binary. There's your bits, right? And there's 8 of them. And then you see the HTML version. You see the hexadecimal. Hexadecimal is base 16. No, base 8. What am I talking about? Hexadecimal. Base 16. What am I talking about? I'm so fucking tired right now. It's base 16, obviously. And then decimal, which is base 10. If you don't know what a base is, a base indicates the number of digits in the counting mechanism. An octal is base 8. So let's just talk about that really quick. This is normally something that I cover in other programming classes. But if you're going to count, I used to do a thing about you're counting against, okay, you have 2 fingers. You're base 2. You're a base 2 person. Okay, now you are we're going to have a counting contest and you're a human. Okay, we're going to count, and you can count from there. And there's a joke. I'm wondering if I should do the whole lesson. I have like a 10-minute spiel about binary, and I think I'm going to save it for tomorrow. But these characters are representations of numbers in binary. And at some point we need to go into binary, particularly since we're doing C. And I don't know when they're going to introduce it in the book. So I'm going to leave that for now. I have a whole lesson on that where I have somebody come up and we do a counting contest and blah, blah, blah. And we actually make a little program to show what the numbers are and how to count them out. But it's really important that you understand that everything is just ones and zeros, and how those ones and zeros turn into other things. That's super duper critical to C coding and in particular, but to all coding, frankly. So, and especially to hacking, and all of that. In fact, when you do hex dump, like if you're going to be a hacker, you get all fancy, right? You're going to hex dump Shatner. You see, this is the code itself, written in 4-byte or 4 hexadecimal values. These are hexadecimal values, which means you go up to 16 instead of counting to 10, which means you can fit more information in a smaller space. The higher the base, the greater the fewer the number of characters are needed. That's why base 64 is used for sending images and things like that, because it's crammed a ton of binary data into a smaller space of digits. There are 10 types of people. I knew it was going to come out. Yeah, that's the joke. I was just about to say the joke. Yeah, the 1 0 is the number for 10. As the number for 10 in base 2, base 10, or digital, or it's the number for 2 in base 2. They get that right? Decimal, sorry, or digital, binary. I'm really tired. I'm not delivering that lesson very well. I just need to walk away from that lesson. We'll just do that whole lesson from the beginning tomorrow. Because I mean, I tell you what, it gives you a real sense of accomplishment to understand the most primitive, finite piece of data that's written to a disk, and how that operates. I mean, that's what C is really good at. So understanding how all data is represented just gives you a tremendous handle on everything else. That's how the internet works. Internet is translated. All that stuff flying over the wires back and forth for our streams. It's all ones and zeros, all of it, and it's all getting translated into these other representations depending on how types are defined, and that's kind of what we got into here. This is our first kind of foray into types, because this is a type. A string is a type. A string is a type. It just means it's a way to look at the same data. This is also a number. Anybody want to know what the number for Shatner would be? Yeah. And what is the number for Shatner? Somebody pull that up for us. I can actually do it. A is 97. You have to count from there. I would love to convert this to binary. We need to convert this to binary so they can see. Actually, let's do that. There's like converters online. Let's just do that. Binary converter. I mean, there's another one. I could probably print it. There's another, but this is something anybody can do. So you go in here. Let's put binary. Let's put. I was gonna put base 2 ASCII Unicode text. Decimal to binary. Let me try it. Shatner. I don't know if this is a good one. Conversion. Number converter. Hex to binary. Decimal to binary. ASCII to binary. There we go. So here we go. So Shatner. Right? Convert. So there's our binary. So this is actually putting spaces. We don't want anything. Right? So that is the same. Now, we don't have any way to represent binary as far as I know. I don't think there's a way in Shatner. If we did, we could do it, right? Yeah, there's the binary though. So if you were to look at the on and off, bits on disk, living on disk, this is exactly what you would see. That means Shatner. And it's a lot of data to deal with, right? So we humans have to make it into other things. And that when we make binary into something else, it's called encoding. It means we're encoding it into numbers or letters or whatever, and we're making it into other kinds of types. So that's kind of fun. And I think we're done for tonight. Don't fall off the end of the string. Oh, hey, look, Shatner. But what happens when C wants to read the content of a string? Say, we covered all this, right? I think we really covered this well, because if you do this, right? Let's do Shatner again. So what I'm showing you here is because we allocated 10 bytes, we have an empty byte. This byte is empty. This byte is also empty, but that's the null byte. Technically, this is a null, and this is also a null, because there's nothing in it. Null just means zero or empty, nothing, all zeros. By the way, this, did you see the binary? Actually, this would be, what would it be, 8 of these? No, yeah, it would be 8 zeros. Don't be confused with the space, which is 32. Absolutely. People, or the number 1, which is not 1. That's what I hate. I hate that the digits, the Arabic numeral digits are not consistent with their binary equivalents. That always bothered me. And change it to char to see if it crashes. You want to change it to a pointer? Shatner.c. A char like that. Yeah, I don't know. I don't know if we want to get into pointers right now, but let's try it. Oh, yeah, it doesn't like that. I might have broken something else though. So yeah, we're iterating over it, so there's no way I would do that. We can't dereference a pointer to something that doesn't exist. We'd have to do it later after that. Yeah. So I don't want to get into pointers yet because it's going to screw. Pointers are the most confusing thing in C. Period. So I don't want to do. Hey, look, they're explaining what I was just telling you. So it actually stores it in memory like this. Is that 0, 1, blah, blah. Here's the 7, the 0. And here, this is why our code we had to define like this. I'm done watching your Rust playlist. It changes my perspective. Rust, thank you. You can still use it as a hobby thing. Just know what you're getting into. That's all I ask. More dumb questions. I think we're almost done. We're not done with chapter 1 though. God, how many do we have? What are the characters numbered from 0? Why not 1? The index is an offset. It's a measurement of how far the character is from the first of the character. Why? The computer will store the characters in consecutive bytes of memory. It can use the index to calculate the location of the character. If it knows that C0 is at memory location 1,000, 1 million, sorry, then it can quickly calculate that C96 is actually at 1 million plus 96. Why does it need a sentinel character? Doesn't that allow how long a string is? Usually it doesn't. C is not very good at keeping track of how long arrays are, and a string is just an array. By the way, what happens when you're dealing with something that's respecting a sentinel character and there isn't one? That's one of the ways that you can hack C code. If you can see something that's expecting, like put S, right? That's expecting a sentinel character and there you pass it no sentinel characters, you can make it do shit that it's not supposed to do. So I'm giving you hacking tips for like problems you can see in C code that can give you a 0 day and make you millions of dollars. So I mean that's not a specific example. I think put C might be not, I don't know, but there are times when data is passed in to something that's expecting to see the null value sentinel at the end, and there isn't one, and you can cause it to do interesting things like keep reading. Depending on the function, how stupid it is, it might keep on reading even past its boundary, in which case now you got a memory buffer overflow, and now you have a hack, and now you have millions of dollars. It doesn't know how long arrays are. No, sometimes the compiler can work out the length of an array by analyzing the code, but usually C relies on you to keep track of your arrays. And this is Rust's contention. That's too much fucking work. That's Go's contention. That's too much fucking work. Any language that's higher than C is removing work for you by adding runtime bloat, a minimum amount of runtime bloat to help you out with that kind of stuff. And that's why people like Python and Go and languages like that, because it gets rid of the risk of all this stuff, right? But when you're dealing really low with stuff, you want control of that stuff. It doesn't matter if it's a single quote or double quotes. Yes, absolutely. I already talked about that. Single quotes are used for individual characters. Not double quotes are always used for strings. This is true in Go. It's true in C. It's not true in Python. It's not true in JavaScript. It's not true in Bash. Python and JavaScript have absolutely no difference between single quotes and double. Bash has a significant difference. Bash and Perl and I believe Python have significant difference. Actually, no. Bash and Perl only have significant differences between single and double quotes, specifically variable expansion. So this is a question you should, anytime you look at any language at all, you should ask yourself, how does it handle quotes? Is it true in C#? Okay. So should I define my string doing shit? That's wrong. Yes. So should I define my strings using quotes? There's a simple explicit arrays of characters. Usually you want to define strings using quotes. They are called string literals. And they're called string literals in every language, by the way. So you'll see string literals in, there's another thing called a template literal in Python and JavaScript. Go has them too. And we'll get into that. But that just, sometimes you'll see strings in some of these other languages with backticks. And that means in Go it means it's verbatim. There's like no substitution at all. In JavaScript it means it's expecting to see template variables in there that'll get replaced automatically. It's kind of like printf. So that's what that's called. And they are easier to type. Are there any differences between string literals and character arrays? Um, and see if you write single quotes, then you miss some signals. Yes. Between string literals and character strings arrays. One, the string literals are constant. Really? String literals are constant? That doesn't seem to be true to me. I don't think they're constant. You're declaring an array. Oh, I see. All right, I want to try something else. All right. So what you're saying is if I do foo, yeah, but that's a pointer. I see. Okay, that's why we couldn't define this earlier. I see what you're saying, because you can't just say foo equals Shatner, foo equals other Spock. This is gonna fail. I know it's gonna fail. I'm just gonna try it. I want to see what the error message says. So, yep, it says it must be declared. Identifiers reported once. If it was undeclared. So if we're going to use a string, it didn't tell us how to initialize a string, but we have to do a string is a character pointer, right? Sharfoo. That means this says it's a pointer, which we haven't. That's why I haven't talked about it yet, because it's introducing pointers too early. Yeah. Hey, how's it going? Thank you, Yarmo. So if we do this, it'll still run it, right? But now let's do the same sort of thing we did before. Foo, we'll say Spock, and then we'll try the same thing. Foo 0 equals capital S, and that should blow up. That should blow up. Yeah, there we go. That's a seg fault. Holy shit. You don't want a seg fault ever. Seg faults are bad. You can't recover from them. We just blue screened. Our program equivalent is just blue screened. Yep. So that's e-money. I think that's what you're hitting it. Yeah. So we have, this is good because we haven't talked about pointers. We're going to talk about pointers tomorrow. This is actually what goes into foo is actually not an array, and that's what's confusing people. What goes into foo is a pointer to an immutable array, which is different. Do you reference foo to try index and one? I think you could still change it actually. I think you can still dump the worker. I think you can actually. Did it actually dump? I didn't. I have dumps off. Oh no, I don't. Where's my core? I have core dumps turned off. Usually, if you do that, you'll get a core dump. You can analyze it. That's what I'm saying. I used to analyze those things for my job at IBM. So, I think we could dereference this actually. I think you could say bar equals foo, and then bar 0 equals s, and then print foo, and it would change the value. If I'm losing you, I'm sorry. I just want to play with this. So actually we'd have to make this a character array. Yeah. We have to make this an array, and it's basically copying it. I'm getting ahead of myself. Did I dereference it right? I did it wrong. I'm getting ahead of myself. Let's not do pointers right now. Let's not do pointers, please. Because I'm getting confused. Pointers confuse the shit out of me anyway. So I don't want to do like an array. It just can't modify the data. I think you can modify the data. I think you can. Yeah, that's what I was gonna do. That's what I was gonna say. It's the reason this is failing is because this is not a thing that you can reference. It's a pointer. So I think if we dereference it, we might be just fine. But if this is how we'll know, because if this crashes, then we know it's immutable constant inside. L value required, left operand of assignment. Yeah. Is that valid? Foo's a pointer. No, foo's a pointer. Foo has a huge fucking number in it. Yeah. You can actually print it out as an integer. How do you do that? Let me think if I can. All right. No, it's not. No, it isn't. Foo zero is not the first one thing. Yeah. Okay. Well, so let's do something besides one. So let's do. I think what you're saying. This is cool. This is a good test because this truly, yeah. I think it's doing magic for us underneath. That should be O. Put us. Yeah, it's not a character. You have to dereference it. That's what I'm trying to tell you. This is a pointer. You can't do this. You can't do this. This is a pointer. Oh. Sorry. Oh. Oh, okay. All right. Interesting. You know what that is? I think that's because it added 2 to the pointer. I think that means that C underneath is adding 2 to the integer value of the pointer. That's what I think's happening. A triangle. Yeah. Are we sure it's read-only memory though? Is it? Do you know if it's the stack of the heap and all that stuff? Do you know which one it is? It's making it as a constant, right? Yeah, I don't know about that. Yes. Oh, that's. Let's do that. I think what's happening under the hood in C is it's doing some pointer arithmetic. I think we're gonna find that out later, but I have a feeling that this notation, guys, I'm sorry, we're geeking out. The beginners, we're kind of done here. We're just geeking out here. I have a feeling that when this is a pointer in this notation, that it's interpreted as pointer arithmetic, and it adds 2 to the base value of foo. That's what I think is happening, and that gives you the character area reference to the data underneath. The question is whether the data is immutable or not, and so far everything indicates that it is. It's read only, so that means that somehow that data is getting flagged on the heap as being, you can't mess with it. It's not. It's either the heap or the stack. I don't remember. The value of the pointer is the position in memory of the first character. Absolutely, and that's what I was trying to print, right? That's what I get for trying to translate when I don't have all my knowledge. Yeah, it depends on immutability. I want to believe you can still change it if you can get to it. I have a feeling we're going to get the same exact value if we do the foo plus 2 here. Who did that one? Yeah. So, because foo is a number, and if we do foo by itself, it'll give us the first item. We're doing pointer arithmetic here. We're like way past the beginning stuff. So please don't get frustrated if you're a beginner. Yeah, it's not even gonna let us do it. Oh, because don't have a fucking param. Oh my god, Rob. Yep, there it is. There it is. That's exactly what it's doing. This is exact. Oh my god, that is so cool. I'm putting that in my notes, in my personal notes. This is super interesting to me. This means that when that all that these are identical. So zet create uh let's see, foo foo plus 2 um same as, let's see, foo. That you know what? I am super happy we dug into that. That's super cool. In C. Want to specialize in C sharp? Yeah. Are we gonna drop out? Don't drop out. I mean, unless you don't like it. You have any tips for me? I don't know what to do. I'm already wasting 1.5 years. Find what you want to do, man. Like look around you, and find out what you would. The most important thing you need is go for a walk. Go for a walk and think about what you enjoy doing. What you want to do every day. You can't really do anything else until you figure that out. In fact, people would argue that's one of the things you're supposed to get from college. College is supposed to allow you to explore yourself and find, your motivation and what you want to do in life and all that stuff. If it's not doing that, then yeah, get out of it. But you got to find that. You still have to find that. If you can't figure that out, you don't know what to do. You can't pick a major. You can't find out who you want to marry. You don't know where you want to live. You have to kind of find who you are and what you want to do. It's tough. Nobody can give you those answers. You got to dig down deep and search. What activities do you want to do every day? And if you can't figure that out, ask another question. What activities do you not want to do every day? I don't want to teach children. I don't want to be stuck in front of a computer. I want to work with my hands. I want to solder. I don't, make a list. And then start looking at lists, and then start researching different careers or activities in the world that involve that. I want to end world hunger. Well, start a band and start, like they did in How I Met Your Mother. There's a meme about that I made, actually. The naked viola guy. I'll have to find it for you. But anyway, I got to write this really quick. So this is hugely helpful for me to realize. The latter notation is just shorthand for pointer arithmetic. I want to write that one down because that was a big discovery for me. RWX. That's the RWW. I have to decide if I want to level up at work. Do I want to do toilsome, painful work all day, or do documents and meetings all day? You can't drink vodka and get paid. I want to be a builder. You can drink vodka. I'm drinking brandy right now. Sort of getting paid. I'm definitely looking at, what do you do for a living? You don't mind my asking? It's on my About page. You can go read that. But I go into exhaustive detail. But I'm an infrastructure engineer. Yeah, I've had my ups and downs, dude. We all do. So, Baz Luhrmann has a sunscreen song, and some of the interesting 40-year-olds still don't know what they want to do with their lives. You gotta figure it out though. Do yoga, practice meditation, go for a walk in the mountains. Whatever it takes for you to get your head right and connect with you, find you. Some would argue that's the whole point of being here on Earth. So, get to it. So, I'm going to play a little video for you. If you can understand it. Let me see if I can find it. It's a good way to wrap up, by the way. Let's see if I can remember. A lot of these are funny. A fish hates dance. Help me. I don't remember the name of it. Flan. I think it's verse. Yeah. The powerful play goes on. And you may contribute a verse. What will your verse be? What are you going to make out of your life? It's your decision. No one makes that for you. Not your parents, that's for damn sure. Not your wife, not your kids. You get to choose. Get on it. It's hard. It's hard. I wanted to be a self-employed entrepreneur who ran his own company and mentoring community. And all of a sudden the world said, sorry, can't do it. You need to work for corporate America in order to live. So I went back to corporate America and I'm still doing this now. So the universe has usually got stuff to work out for you. You just have to figure it out, in my opinion. So, do I have a drive out my system named TV? No. Oh, yes. Why? Are you trying to attack me? No, the name of my system is TV. Yeah. Is it Terminal Rick Astley? No. Lol. I think we're good. I think we're good on that C program. Where do we get? So we got past here. We got through painless operations, decrease. We're gonna have to come back to that. Types of commands. It sounds like we got about half of chapter 1 to go, but so when I programmed your age, when I was what? How old are you? 20? You're 18 or 19? Fuck no. I was dancing and kissing girls. And then I went on a mission for the Mormon and skiing and skateboarding and water skiing and snow skiing more. and going to the beach. And then I went on my mission from the Mormons. And I came back, and in college I started getting into coding again. I got into coding a lot when I was 12. In fact, 12 is a magical age. If you're a parent, I'm going to give you some advice here. Okay. If you're a parent, there is a magical age. From about 11, I would say, till 13 or 14. 13, 14, 15 is pushing it. It's a magical time. I've dealt with hundreds of people of different age ranges, but that particular range is very magical. Let me tell you why. Those kids are still they're smart enough, and they've been through math, that they're smart enough and they're hungry to really want to learn something interesting. So they're really primed to learn Python, to learn how to do Minecraft servers, to learn how to hack, to learn all those things. They still think games are cool, but they're kind of moving away from it. So they're looking for something a little cooler, like maybe hacking, maybe coding, whatever. And then they haven't discovered girls yet. They haven't been hit really hard with hormones yet. They probably have some hormones, but they haven't been hit really hard with them. They don't have a car yet. And they are perfect candidates to get into coding. Any kind of mentoring, anything you can do. And that was my situation. My situation was I coded like crazy when I was a geek. When I was like between the ages of like 10 and maybe 14 or 15. I got my car. Girls started looking at me. They thought I had a quote dancer body or whatever the fuck. And then I started to skate. I started to be obsessed with chicks and music, and I would air guitar sticks music and Depeche Mode, and we would go dancing 5 nights a week. So what I'm trying to tell you is that by the way, I'm confessing to you, between the ages of, I want to say 15, I will never forget kissing Melissa Bigley on that patio, and that was the end of me. That was the end of me, my coding. It was the end. It was like 15 or 16, and all I gave a shit about was trying to attract the opposite sex and doing athletic things. That was it. I had no interest whatsoever in coding. I could do it, and every once in a while I would do it, and I would use the computer as a tool, to a means to an ends, to like prepare my, I don't know, my campaign slogans and everything. And then and then all that happened, and then so I didn't start coding again until I was 21, 22. And I was back in college. I got back from my Mormon mission. I was going to school, and I was learning computers. I took computer science and fucking hated it. I checked out of physics because I kid you not, at the time I used to say there's no cute girls in the physics department, and I realized that was just because it was BYU. There's absolutely totally cute girls that are into physics. I just hadn't met any, and obviously my hormones. I was Mormon. That means I didn't get to have sex with girls. which meant that it was constantly on my mind. And you didn't want the whole story, but the end result of the story is I didn't return to programming until I was 21 or 22, and then the internet came out. And when the internet came out, you couldn't stop me. You couldn't stop me from coding. Mormon Mission, it's a church. You know, the missionaries that wear the white shirts and ties. Because the brandy, yeah, I gave up Mormonism a long time ago. I'll tell you that story another night. It is Friday night after all. Maybe we'll do a little bit of that after that. I do want to wrap this VOD up and go ahead and put a mark in it. And I'm just going to reset really quick so that this VOD is just C coding and a little bit of anecdotes going on. I am not left-handed. No, I wish I was. Or my wife is. No, I'm very, very left-brained. Yeah, I mean that's not a thing. They've come out and debunked the whole thing, but it's still used as a reference to analytical versus artistic creative. We're all creative. Coders are creative. So I'm going to save my code here, and we're going to wrap up this section. And you're welcome to ask me more questions as I game or do whatever. I might play another Dota game here because tomorrow is Saturday. Tomorrow I am going to do Asana though, no matter what. So I'm not going to stay up too long. And remove Shatner here. I'm going to add the code I changed. So I need to actually update my git ignore as well. So can you do wildcards and git ignore? I wouldn't want to do that anyway. Never mind. So I want to do chapter 01. Hello. Chapter 01. There we go. And then we need to add our new ones. So Shatner. This is keeping the executables from being stored in my Git. So I'm going to add everything recursively. See what it added. There we go. Got it. Look at all that stuff. And we're going to commit that. Smash that follow button. Your regex like this? Yes, you can. Information, bro. I'll definitely be following more. Yeah, come on by anytime. We're going to be here every night doing C game development from 8 to 9:30. Every night. Pretty much every night. So if you just want to check in. I also do kind of coffee talk in the morning at 8 a.m. Like from 8 to 8:45 or so. It's just me in my pajamas and drinking coffee and talking about random shit. So if you want to get in and do that. Actually, that's not true. We're going to do that at 9 o'clock. I need to change the schedule because we're going to do Asana in the morning before that. That's right. So, I mean, just, stay tuned. Yeah, thank you for the reminder. Thank you for that. By the way, I'm not going to push it. Dumb chicken. Biryani. What time zone is down here? Eastern? Oh, you can't see it. Sorry. Time zone is here. Yep. All right. So, not Fox News. Lol. Add chapter 01, and then we're gonna git push, and that'll get us on our way. I feel like we're making progress. We might not be making the same type of progress you were hoping, but it gives us an opportunity to supplement what's in the book. Eastern. I'm in North Carolina. Yep. I'm in North Carolina. You can see videos of me outside skateboarding and crashing and burning and stuff if you want to see North Carolina. It's a really beautiful, beautiful state, actually. Sometimes the people are a little hard to deal with, but for the most part. Gaming here for Dota 2? No, actually. I mean, I totally fucking stomped with Crystal Maiden without it with my Mac keyboard, so... I am not in Cali, no. No, I only lived in California for 2 years as a really tiny kid. I lived in Anaheim. Had really bad asthma, by the way. Now looking back, I think I know why. Covered in yellow dust. Oh, yes. I think I know exactly what you're talking about. That's the morning. That's the spring. Let's just say we're close. Nothing wrong with that. I'm very, very close. I'm in Mooresville, North Carolina. Too many tutorials confusing young programmers by showing off the present planned coding, but never show mistakes or factoring. that are boring stuff that we do. See, yeah, that's the stuff, Lord Rubbish. That's the stuff people need to learn. That's the why fucking around with the code is always the best way to learn. And I think doing it, most successful programmers have learned to either do that themselves as an autodidact, or they have got a pair programming situation going on where, and that's my goal here, is to basically pair program with y'all. And I kind of like it because my C is so fucking rusty. I mean, I haven't I haven't written C for 15 years. 2014 was the last time I wrote C. So, yeah, that's not 14 years. That feels like it, but it's long, yes. Dota 2 again. Alan, don't blame me. If you want to come play with me, you come log in. Send me a friend request, rbxrob.tv. Yeah, send me a friend request. Let's do it. I'm gonna cancel the stream. I'm gonna come right back, and we'll play a little bit of Dota. I'll be under the Dota category when I come back, because it's Friday night.